Now we'll talk about something called average rate of change, and sometimes we just abbreviate this to AROC. So average rate of change, I find that students get freaked out by this, I think because this formula looks a little crazy. F of x minus 2, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. That looks a little intense, a little bit scary. But when I see average rate of change, I'm just thinking about a slope. This is basically a fancy slope that we're trying to find. So graphically on this line down here, not on this line, but on this curve down here, this nonlinear graph, if we want to find the average rate of change from x sub 1 to x sub 2, what we're doing is we're identifying those points on the curve, right? So I follow x sub 1 up there, and of course this is going to match up with some y value. So we could call it y sub 1, right? So I can say that ordered pair is x sub 1, y sub 1. For this x sub 2, if I follow that x value up and I identify it on my curve, that's going to line up with some y value. So I could call this point x sub 2, y sub 2. So we can't talk specifically about a slope of a curved function like this, of a nonlinear function. But what we could do is we could identify 2 points along the curve, and then we could connect those 2 points with a straight line. This is called the secant line between these points. So we're kind of fitting a straight line on top of this curve, and we're finding the slope of this secant line. So when we're talking about the average rate of change between two x values, we're finding the slope of the secant line that connects these 2 points on this curved function. Okay, so we could think of this point, these 2 points, as x sub 1 and f of x sub 1, or x sub 2 and f of x sub 2, or that's really just saying x sub 1, y sub 1, x sub 2, y sub 2. Because, if you guys recall, y equals f of x. Those are the same things, right? So where we're talking about f of x sub 2, that's just the y value when we plug in that x value. So this formula here, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, I'll keep my x's in the denominator. Where it says f of x sub 2, that's really just the y value. So for x sub 2, what's the corresponding y coordinate, y sub 2? Minus f of x sub 1, I'm just going to write minus y sub 1. We're basically finding the slope, right? So when you see average rate of change, I kind of ignore this scary formula. I just find use my x values to find my y values, and then I use that to find my slope. So the only extra stuff that you're really dealing with here is normally you're given, an x and a y value, right? So you're normally given the full 2 ordered pairs, and you're asked to calculate the slope between the two. In these examples, you'll be given your x values, and you'll need to find the y values on your own first. So as a first step, you need to calculate your y values, and then you've got your 2 ordered pairs. So in number 6, the revenue in dollars from the sale of x calculators is given by the function f of x equals 10x minus 0.01x squared. What is the average rate of change in revenue if production has changed from 100 to 400 calculators? So those are our 2 x values. So suppose x sub 1 equals 100 and x sub 2 equals 400. We want the average rate of change between those 2 x values. So the only new thing is, for our first point, we have 100, but I don't have my y value, right? So to find my y value, I can evaluate my function at 100. So I can take f of 100, which would be, my calculator, 10 times 100 minus 0.01 times 100 squared. And that gives me a y value of 900. So I'm just plugging f of 100 into this function, right? So what I just found out is that I have the ordered pair 100, 900. So that's my first ordered pair. For my second ordered pair, I know x sub 2 equals 400. So I know my x value equals 400. I need to fill in my missing y value. And to do that, I'm going to calculate it using my function. F of 400 would be 10 times 400 minus 0.01 times 400 squared. Oops. 400. Clear that out. Sorry, got to start over. 10 times 400 minus 0.01 times 400 squared. Okay, there we go. And that gives me 2400. So that means I have the ordered pair 400, 2400. So what I'm doing is I'm finding the slope between 100, 900 and 400, 2400. So you could think of this in terms of this average rate of change function, but really I'm just thinking of it as a slope function. My slope is going to equal 2400 minus 900, subtract my two y values, over 400 minus 100, my two x values. 2400 minus 900 gives you 1500. In the denominator, 400 minus 100 gives you 300. And 1500 divided by 300 gives you your answer of 5. So average rate of change is 5. And again, what this represents is it's the slope of the secant line connecting those 2 points on this parabola, this downward facing parabola. So if we go to x equals 400, so maybe like right here, 400, 2400 will be about here. And our first point, 100 and 900. So maybe that's 100, that's 900. And what we're doing is we're imagining that there's this line connecting those 2 points, and we're finding the slope of this line. And we can see that that's a positively sloped line, and it's a pretty steeply sloped line at that, so that's why we ended up with that slope of positive 5. All right, so what's the average rate of change? What's the average rate of change of f of x equals x squared plus 1 from x sub 1 equals 0 to x sub 2 equals 1? So the only new thing compared to a slope problem is if x equals 0, then we need to find our y value by plugging 0 into my function. So this would be 0 squared plus 1 equals 1. So I have the ordered pair 0, 1. And then for x equal to 1, if I evaluate f of 1, this would be 1 squared plus 1, which equals 1 plus 1, which equals 2. So this tells me if x equals 1, y equals 2. So I'm finding the slope between these 2 points. 2 minus 1 over 1 minus 0 gives me 1 over 1, positive 1. So that's my average rate of change. For b, using the same function, if my x value equals 1, if I evaluate f of 1, this would be 1 squared plus 1, which gives me 2. So I have the ordered pair 1, 2. If x equals 2, f of 2 equals 2 squared plus 1, which is 4, plus 1, which is 5. So I have the ordered pair 2, 5. So to find the average rate of change, I'm just finding the slope between those 2 points. I was given the 2, I was given the 1, I had to find the corresponding y values by plugging the x values into the function. So for the slope, 5 minus 2, subtract my y values, over 2 minus 1, gives me 3 over 1. So average rate of change is 3. And finally, for c, again, we're still using that same function, f of x equals x squared plus 1. If x equals negative 2, f of negative 2 equals negative 2 in parentheses squared plus 1, which is positive 4 plus 1, which gives me 5. So I've got my ordered pair negative 2, 5. if x sub 2 equals 0, f of 0 equals 0 squared plus 1 equals 1. So I have the ordered pair 0, 1. My average rate of change will be the slope between those 2 points. Oops, 1 minus 5. 1 minus 5 over 0 minus negative 2 gives me negative 4 over 0 plus 2, so positive 2. So average rate of change of negative 2.